Okay, good morning, everybody, or afternoon, depending on when you're watching this, I guess. So happy Monday. This is our second week of actually starting things here. Before we actually start into the new stuff today, what I want you to do is take a quick look at these. I'm going to give you a second to do this, and I want you just to pause the video after I give you these directions here. What I want you to do is to take these things that it says here. I'm not going to read them off yet, but after you try it, I will. And mark those things into the picture using the tick marks and the angle congruent marks and all that kind of stuff. Same thing here. Take this information, mark it into this picture. Pause your video now, and then we'll come back and go over those real quick. Okay, so first thing I want to do here with these is just make sure that we've read through kind of what this is saying. So that very first one there, we've got line segment BC is congruent to line segment CD. And so if we're going to mark that down, we'll do that in red here. Line segment BC is this one. So we'll put one tick mark there. And it's congruent to line segment CD, which is this one. So we'll put one tick mark there. So that's this part in red. Next part we'll do in green here. Angle BCD is a right angle. And so BCD, remember that middle letter there is the vertex. And that means that this is a right angle. So we put that little square in there. Moving on to this next one. We've got angle EHG, H being the vertex there. So that's this angle. EHG, the angle it makes there, is congruent to angle FGH. And so FGH is that angle. G in the middle there is the vertex. And it's saying that those are congruent. So we put the little tick marks right in there. And then our last thing here, we've got HG is parallel to EF. And those are the line segments. HG and EF are parallel to each other. And we show parallel with the angle markers there. So that kind of stuff is going to be really important later on. You're going to see things like this, and being able to get that information out on the paper, or being able to see it on the paper and know what it means, is going to be really, really important. Okay, up next, a couple of common misconceptions that I always see. Angles 1 and 2, if we remember what we're called there, think about that. Those are called vertical angles. They do not have to be up and down. 5 and 6 are also vertical angles. They just have to be across from each other like that. So when two lines cross, the angles across from each other are vertical angles. These ones over here, I don't know if that's how I spell that. These ones over here are called a linear pair of angles. And the linear pair is just going to be two angles that share that common side, and then they make a straight line. Now, one other thing that we know about a linear pair of angles, they are also supplementary, because they form a straight line, and a straight line is 180 degrees. So a couple of those things showed up on the quiz, and those are just common mistakes that I always see every year in the beginning, because those are new things for sure. Okay, so today we're going to be talking about polygons. We've got some vocabulary here. First of all, what is a polygon? We'll talk about a vertex and a side of a polygon. We'll talk about the diagonal of a polygon. That diagonal, that's a noun. If you're into English stuff, you definitely heard the word diagonal used as an adjective, like a diagonal road or something like that. But this is a noun, a diagonal. And we've got convex and concave, and perimeter. Hopefully, remember what perimeter is. But we'll talk about that real quick. So first definition here, a polygon. I'll get my face out of the way here. I'm thinking you can see my face there. Polygon is a closed figure in a plane formed by connecting line segments endpoint to endpoint. Now, the part that I crossed off definitely has to be true, but if you don't want to write that part down, that's fine. Each segment intersecting exactly two others. I don't really see how you could do that with more than that, but That's a polygon. Now, a couple of examples here. These are all polygons. Something like this, maybe you haven't seen before, where one of them kind of juts in and then back out. That's still a polygon. It meets our definition. It's made of segments. They're connected at their endpoints, and it's enclosed. Some of these over here are not. This one's not a polygon. These two segments don't connect at their endpoints. These aren't made of segments. They've got curved lines. This does not enclose a space. This one, again, not an enclosed space. Those two segments cross somewhere that's not their endpoints. So we've got a problem there. Those are polygons. Those are not. Now, for our polygons, we're going to be able to classify these by the number of sides. And so each polygon with a different number of sides has a different name. If it has 3 sides, I think we probably all know that that is a triangle. And I want you to know up to 12. So I want you to think on your own here while I go. 3 sides is a triangle. Think about what 4 sides might be. 4 is a quadrilateral. Now, the things that you know, like squares and rectangles and things, those are types of quadrilaterals, but generally we call it a quadrilateral. 5, think about the pentagon in Washington, D.C. It has 5 sides. A 5-sided shape is a pentagon. 6 will be a hexagon. Hex always means 6 there. 7, this is the one that we don't see very often, a heptagon. 8, you probably know that one is an octagon. Or a stop sign, that's an octagon. 9 is a nonagon. 10 is a decagon. You probably know that one. I'm going to guess 11 is probably one almost nobody knows there. Undecagon or an undecagon. That one you really don't hear all that much. It's a very uncommon one to ever use. 11 is just not a nice number for most things. And 12 is a dodecagon. Anything past that, and you'll just see whatever gon. So you might see something like a 13 gon or a 22 gon. Don't worry, I will never make you draw a 22 gon. That's just mean. Okay, moving on. That list is something you might want to, if you want to pause the video and write those down, you do need to know those, because at points I will say, you have an octagon. And if you don't know that octagon is 8 sides, well, right away you can't do that problem. Okay, so here's what I want you to do. If you've got some paper you're taking notes on, great. If you've got a piece of scratch paper that you can do this on for now, that's great too. But this is something you're probably going to want to keep because it's going to have your definitions on it. I want you to draw a 5-sided polygon on your paper. That is called a pentagon. At this point, pause your video while you do that, and then once you're ready, go ahead and start it again. Okay, welcome back. So we're going to label the following things on this polygon. We've got a side, we've got a vertex, we've got a diagonal, and there's my polygon. So I have a feeling the first one, side, isn't going to be too shocking to you. The sides are these things. So this being a pentagon, it has 5 sides. I bet most of you probably knew that. A vertex. If you think about what a vertex is in an angle, this probably makes sense, but the vertex is going to be the corner. Plural is vertices, but again, our pentagon has 5 vertices. Now, a diagonal. Again, this is a noun. It is a thing. A diagonal is going to be any time that you connect 2 vertices that are not already connected by a side. So that is a diagonal. That is a diagonal. A pentagon actually has quite a few diagonals. I believe it's 10. I think it's 10. You can try drawing them all out. Count them out and see how many there are in there in your pentagon. I think it's 10, but don't quote me on that. So those are the big ones. Side is the actual sides, the line segments. Vertex is the points where they meet, and the diagonal is a line segment that connects 2 vertices that aren't connected by sides. One more definition here. We've got convex and we've got concave. Now I've put 2 things on here for you. The smaller ones are the technical book definitions. So a convex polygon is where you draw all the diagonals and they're all on the inside of the shape. I always remember this as all the vertices point out. Okay, they all point out, the little vertices. Concave polygons is where one or more diagonals are going to be on the outside of the polygon. So mine here that I drew was concave because one of the diagonals is outside. Now, when I learned this in school, I actually first heard this in science class when we were talking about concave lenses, I think. Cave is the key there. If you think about this shape right here, imagine a little cave person hanging out in that little cave. That's how we know it's concave. Polygon goes in at some point. So you see how you got like little back in and then back out. Okay. Now, the next thing here we got to talk about is congruent. Congruent polygons. I'm going to try to get myself out of the way here. So polygons are congruent. This little symbol kind of means if and only if, or the definition of. It means that all sides and all angles are congruent. And so you can see we've got a quadrilateral here, CAMP and SITE. And you'll see that angle C is marked congruent to angle S, angle A and angle I, angle M and angle T, angle P and angle E, and then side CE and side SI, side AM and side IT, side MP and side TE, side PC and side ES. So we've got 4 congruent angles and 4 congruent sides. That's what you got to have. If it's a pentagon, you got to have 5 and 5. There's a lot of information there, but that's what congruent means. Exactly the same in every way, except for, you notice this one's kind of turned a little bit. That's okay. So the notation for this is, first of all, we have the notation for a quadrilateral. In this case, has just the 4 letters. We label off the vertices. There's no special symbol for these. And so I noticed a few people last week when you were doing these assignments were writing down things like ABC without an angle symbol in front of it. Without that angle symbol in the front of it, how do I know if you're talking about an angle or a triangle? I don't know. So if it's an angle, you have to have the angle symbol. If there's no angle symbol, we're assuming probably that it's a polygon, not an angle. So this is saying that quadrilateral CAMP is congruent to quadrilateral SITE. Now there's a lot of information in that short little piece of information there. First of all, we're claiming that those 2 quadrilaterals are congruent. That's the simplest version there. Now, the other thing that we have to make sure that we're doing is understanding this part. When we write these down, the order that you write the letters in is important. CAMP is congruent to SITE. Because the C and the S come first in both of them, those 2 vertices match up, and they are congruent themselves. Those angles are congruent. If I look at, for example, these 2 letters, M and P, S and T, those go together, that's going to tell me that segment MP is congruent to segment TE. So every little piece that you pick out of there is important. And so it's really important that you've matched these up. If I, for example, tried to say that CAMP is congruent to, let's just say TESI, that is not true at all. Even though those are both valid ways to name this polygon, that's not true because the C and the T are not the matching pair. The fancy word is corresponding pair. So the order you put them in has to match. And so just to kind of drive that point home here, this one I think I'll actually have you pause the video and answer. We'll say that for the purposes of this one, I'm going to make a multiple choice. That's A, that's B, and that's C. So A, B, or C, which of those polygons is congruent to polygon ABCD? Okay, so when you're trying to answer this question, remember it's got to be all the angles and all the sides congruent. And so one thing I'd look for is, okay, if I'm looking at A has 2 marks. do I see an angle with 2 marks in it kind of in the same general position? So I see that there, I see that there, I see that there. Okay, that doesn't help me. Next, I'm going to look maybe at these angles. Both of those 2 angles are congruent to each other. So I'd look and say, okay, well, there and there, there and there. Oop, not enough information. This one's definitely out. And then I might look at these angles. Right angle, right angle, right angle, right angle, right angle, right angle. Okay, so far with angles, I've eliminated C. I'm going to go ahead and erase those because that's, oops, a little too much in the way to do the next part here. So C's out. Moving on here. Okay, now let's look at the sides. You can see on this one, the bottom side, DC has 3 marks. If I'm looking at this one, I've got 2, 2, 1 and 1, 1 and 1, 2 and 2, 2 and 2. I'm missing something there. So it can't be that one. But on this one, I've got that. And you can kind of see that's been turned, of course, but let's double check it. It could be none of these, so we definitely want to check. Next, I've got those 2. Yep, definitely. And then I've got those. And they're there as well. So it's definitely B. Now the question is, can we write what's called that congruent statement? A, B, C, D, E is congruent to, and we have to match the letters. So let's go through them one at a time. A matched up with N. B, if you envision that being turned, B matched up with P. C matched up with Q. D matched up with L. And E matched up with M. So even though you think, oh, I just put them in the letter order, LMNOP or LMNOPQ, nope. You have to make sure you're matching the letters. A went with the N. Those were the congruent angles. Going kind of counterclockwise. Or sorry, that's clockwise. Going clockwise, P and B, Q and C, matching them up as we go. If you were to have written this A, B, C, D, E is congruent to L, M, N, P, Q, that's wrong. Those polygons are congruent, but not in that order. Okay, and then the last one we had to talk about here was perimeter. So perimeter is going to be the distance around a polygon. That's probably something that you've known already. Pretty straightforward in how you're going to go about going about doing these. You've got here a quadrilateral, 4 sides, and if I want to find the perimeter, I just add them all up. So I've got 12 plus 15 plus 5 plus 5, and it's going to be 20, 35, 37. And of course, if you don't include the centimeters, it doesn't really mean anything. So 37 centimeters, add them all up. Okay, we got 3 more slides here, and then a conclusion question. So, first up, let me get my face out of the way again. Equilateral polygons. This is one of those things where I want you to try to come up with a definition, and then afterwards, we'll talk about it. So, type in what you think the definition is based on the fact that these 4 are equilateral and these 4 are not. And just as a reminder, before I pause the video, how these work. You always want to have your definition that classifies it. An equilateral polygon is a blank, and then differentiate it. That blank. What is it? How is it different from all the others? Go. Okay, welcome back. So in this case, we're definitely going to want to start this off with something like an equilateral polygon is a, shocker here, polygon that, and then what makes it different from all the other polygons out there? And you'll notice here we've got these congruent marks everywhere that has all equal sides. Something like that would be a good definition there. An equilateral polygon is a polygon that has all equal sides. We could probably use the word congruent if we wanted to. That'd probably be a better word. Now, a couple of things here. This one has all equal sides. Why isn't that an equilateral polygon? The answer is because it's not a polygon at all. Okay, next one here, same rules. Write a definition for equiangular polygon. Okay, welcome back. Equiangular polygon. I gotta get myself out of the way there so you can see. An equiangular polygon is a polygon that has all equal sides angles. Can you tell I'm not very good at this typing thing? And again, instead of equal, it wouldn't be a terrible idea to go ahead and put congruent. But of course, those mean pretty much the same thing. So equiangular, all equal angles. Final one here, irregular polygon. Take a look at those two pictures and try to write down your own definition. Okay, welcome back. There's a couple of ways we can do this. A lot of people will probably go with a regular polygon is a polygon that has all congruent angles and all congruent sides. That would be perfectly fine. Another option would be to say a regular polygon is an equiangular equilateral polygon. So what we can do is we can actually use the terms that we just defined to make this definition shorter. So by saying that this is equiangular, that's the same thing as saying it has all equal angles. Saying it's equilateral means that it has all equal sides, and it is also a polygon. And so you've got things like squares. 4 equal sides, 4 equal angles, that's a square. Okay, last thing here. Again, think about these. Maybe pause the video. I'm not going to have you write these ones in here. What are the characteristics of a regular hexagon? Think about what you would know there. And so regular is going to tell you it's got 6 equal angles. It's got 6 equal sides. And the reason I know it's 6 is because it's a hexagon. Later on, we'll talk about what else we know. If it has 6 equal angles, there's a good chance we can figure out what those angles actually are. But for now, we'll just know that they're all equal. What is the difference between convex and concave? Think about that. Okay, so remember convex is where all the vertices point out, and a concave is where at least one of them kind of points back in on itself. And are polygons with the same perimeter necessarily congruent? What do you think? The answer there would be a definite no. You could have polygons that have the same perimeter that don't even have the same number of sides. So definitely not necessarily congruent there. Okay, so there will be a few homework questions for this video that goes along with this video. And then there also probably will be another video that goes along with the next section here. And so the next section is all about triangles. And then after that, we're going to be talking about quadrilaterals. So those are the last 3 sections here that we're going to talk about in this chapter. Is a whole section on the vocab of triangles and a whole section on the vocab of quadrilaterals or 4-sided shapes. And actually, let's do this. Those 2 will both be on Wednesday. So we'll do 1 today, we'll do 2 on Wednesday, and then again, we'll have a little vocab quiz Friday. Kind of looking forward to what's coming up this week. I will see you all tomorrow in the Zoom class. We'll talk about more of this. We'll do a little bit of practice together. We'll definitely be doing a little bit of this stuff too. This is kind of some of the hardest stuff for most people. So see you then.